Hello everyone, now I will present my research paper. The title is Multiple Representation Based Chemistry Learning Textbook of Kadek Topic. My name is Widiastari and I'm with Mr. Rodani in this research. We are from Universitas Pendidikan Ganesha, Singaraja, Bali, Indonesia. So let's move to the background. Chemistry discusses the properties of matter, the structure of matter, the change of matter, and the accompanying energy. Chemistry not only discusses phenomena at the macroscopic level, but also discusses them at the submicroscopic and symbolic level. Chemistry concepts at the macroscopic level are the concepts related to the real phenomena. The concepts at the submicroscopic level are concepts that explain macroscopic phenomena related to the information about atoms, molecule, and kinetic aspect of substance. The last, the symbolic level, are concepts related to the use of symbols, diagrams, and formulas. Understanding chemistry deeply can be achieved if students can understand the interrelationship between that three levels. However, the representation of chemistry, particularly in the submicroscopic and symbolic level, cause students experience difficulty in understanding chemistry concepts. This is due to the submicroscopic and symbolic level were abstract concepts. Both of these levels will make chemistry less attractive to the student because students cannot imagine the concept of chemistry at the particular level. Helping students to understand chemistry well can be done by displaying various representation, and we can call it multiple representation. The use of multiple representation must be part of learning material, textbook, and media so that they can bridge all the three levels of chemistry concepts. Based on that, it is important to investigate the effect of using the multiple representation-based chemistry learning textbook on student learning outcomes. And the goal of the study was to compare the effectiveness of multiple representation-based chemistry learning textbook and the conventional chemistry textbook on student learning outcomes, especially on Kadek topic. Method. This study is a quasi-experimental study with the non-equivalent pre-test post-test control group design. The population of this study was the 11th grade student of SMA N4 Denpasar, Bali, which consists of 8 classes majoring in mathematics and natural science. Samples were taken by a cluster sampling technique. The number of samples taken was 2 classes. Both classes were grouped to get control group and experimental group. The control group consists of 36 students, and the experimental group will consist of 35 students, respectively. The stages of learning carried out in the two groups were the same, namely scientific approach, but the differences in the treatment given to the control experimental group were the sources of learning. At the control group, students used conventional chemistry learning textbook, which is the common textbook that used by teacher. And at the experimental group, students use multiple representation-based chemistry learning textbook. One model of multiple representation contained in the textbook was shown in figure 1. This is the concept of differences between solution, colloid, and suspension. In this study, pre-test and post-test were conducted to get the data of students' learning outcomes, and the data were analyzed using a statistical technique, namely analysis of covariance or ANCOVA at 5% of significant level. Result and discussion. The pre-test and post-test were conducted in both group, control and experiment, using the same test to obtain the student learning outcome data. A summary of student learning outcome data was presented in Table 1. From the summary of pre-test and post-test, at the pre-test result, experimental group got the higher mean score than the control group, and at the post-test result, experimental group also got the higher mean score than the control group. After we got the data of pre-test and post-test, next, the data were analyzed using ANCOVA. However, several assumption tests had to be fulfilled first before we conduct ANCOVA. namely test of normality, homogeneity, linearity, and slope of the regression line. Based on assumption tests that have been carried out, all data obtained met the requirement. Thus, we could continue the uncovered test. The result of uncovered test could be seen on the table 2. On the table summary of uncovered test, we focus on the group rows, and it shows significance 0.000. So it's lower than the significant level. From that, we can conclude that null hypothesis was rejected and alternative hypothesis was accepted. So there is a significant difference in learning outcomes between students taught by using the conventional chemistry learning textbook and students taught by using the multiple representation-based chemistry learning textbook. The use of multiple representation-based chemistry learning textbook as a source of learning is very effective in improving the students' learning outcomes. This is caused by the textbook display 3 levels of chemistry concept, namely macroscopic, submicroscopic, and symbolic level that are relevant to the characteristic of chemistry. This is the other example of the multiple representation. We can show in figure 2. The figure 2 shows a colloid concept, especially in coagulation. The visualization of the 3 levels of this concept can help students to understand chemical phenomena that are mostly related to the submicroscopic level, which is the particulate level. And learning with multiple representation also optimizes the ability of students to imagine and interpret overall chemical phenomena, improve student listening ability, increase student critical thinking, foster student creative thinking skill, and reduce student misconception. In addition, all 3 levels of representation can also improve student reasoning abilities, and student understanding becomes more meaningful and it's stored longer in the brain. And the right learning strategy will be able to reduce student misconception, thus student will get satisfaction in learning chemistry. This is the conclusion of this research. Chemistry learning should pay attention to the interrelationship of 3 levels of chemistry, including macroscopic, submicroscopic, and symbolic concepts, using multiple representation. The use of multiple representation in chemistry learning can be done by integrating them into the chemistry learning textbook. The results show that the pretest post-test score in the control group was 36.86 and 70.92 respectively. On the other hand, the pretest and post-test score in the experimental group were 46.66 and 79.43 respectively. Furthermore, the result of statistical tests indicate that the multiple representation-based chemistry learning textbook is better than conventional chemistry learning textbook in improving student learning outcomes. Therefore, this textbook can increase student imagination in understanding chemistry concept and can improve student critical and creative thinking skill. This textbook can be applied by chemistry teacher in improving student learning outcomes. So that's all that I can be present to you. You can ask me if you have any questions. Thank you.